is a topic that some schools, they teach it in Sec 3 as the first topic. I know the reason, but I didn't do so. Why? Because it's very boring. As I mentioned, it's not technical. It's very conversation and becomes very boring. Nothing much to like play like mathematics like that. All right. So this is highly linked to your practical. So your Sec 3 students, your Sec 4 students will tell you, hey, yeah, I saw them here and there in practical. Okay, your chemistry practical. So you'll be doing your hands-on. All right, plus the next topic. So here we go. I think it's about time that we enter already. Now, first of all, it's called measurement. Very boring at the start, I agree. All right, but each of them is 1 mark in exam. A stopwatch or a stop clock is used to measure time accurately. So what do we use to measure time? A stopwatch, if not a stop clock, consider done. In exam these days or in schools, nobody uses a clock anymore, so it's called a stopwatch, all right? Here we go. A thermometer is the only apparatus used to measure temperature and it's always, in a way, accurate, all right? Accurately. What about the third one, all right? Your mass. To measure your mass, we use an electronic or a beam balance. What is the difference? An electronic balance basically is digital. A beam balance looks something like, I can't really draw, but let's say you go like that. It's like seesaw. Everyone okay? So it's a beam. All right, a beam balance. But all in all, it measures mass. Each of them is 1 mark. This is not interesting to me, but it's more interesting that students start to lose marks is the following up. It's the measurement of the volume itself. A measuring cylinder is used to measure, again, volume of liquids. You really look at them, these are all volumes of liquids. So these are used to measure the volume of liquids, all of them. Okay, so I'll just put it here first. These are all used to measure the volume of liquids. But there is differences that you need to be very clear about. A measuring cylinder measure to the nearest 0.5 cm cube. So we are looking at values of example. It's good to have example in your head. 31.5, 23, 23.5, 24, 24.5. Okay. What about a burette? A burette has an additional word. It's the word called accurately. So I would like to use pink for this, let's say, accurately. It's very precise because of the way we made it. I'm from the chemical industry. By the way, I'm not a school teacher, not trained in NIE. I'm from the industry. My company, not mine, but I work for, has been selling burette and all these things. Okay? I've talked to the scientists who make all these measurements. They are very, very precise, a burette. A pipette is also very, very precise, just like a volumetric flask. They are very precise, which also means the measuring cylinder is not precise. It's just used for a rough measurement or rough gauge. For example, I want to cook instant noodle at home. I just need to know I put a certain volume of water. Mixed by 0.1 or 1 cm cube. Does it matter? No. I'm going to cook the noodle. All right? It's not precise. Now, let's talk about the precision, which unfortunately you need to know. Remember, I tell you, usually, I don't want you to memorize anything, but when it's time, especially at the start, you need to memorize, you've got to memorize them until you get used to them. A burette, measurement-wise, is to the nearest 0.05 cm cube. So we are talking about what? We are talking about volume of something like, example, 21.55 cm cube. If it's exactly on that number, called 28, you cannot write 28. I repeat myself, you have to write it as 28.00 cm cube because this is its precision. You have to write like that. You cannot write 28 cm cube when it comes to a burette. A pipette, same thing, but pipette are even more special. A pipette measure fixed volume. Later, I'll show you the shape, how they look like, in case you haven't seen before. So we are looking at what? We are looking at things like 10 cm cube, 25 cm cube, 50 cm cube. So they have a standard sizing in the lab. And in your school, usually you will handle the 25.0 cm cube. A volumetric flask measure, once again, a fixed volume. So these two are fixed, the pipette and the volumetric flask. These are for volumes that are larger, like what? 100 cm cube, 250 cm cube kind of flask. I repeat myself, 3 of them are precise, accurate measurement. First one is not. You need to know their precision. Those went to a lab, my Sec 4 will concur. When you do experiment, when you break a measuring cylinder, usually the smaller one, the teacher won't scold you. Okay, say, they will maybe just keep quiet a bit. They'll say, okay, then I take a new one. If you break a burette, a pipette, or volumetric flask, they'll start to yell. If you break 2 for the same experiment, they're just playful clumsy. You break 1, then they'll just stare at you. Okay, take a new one. You break another one, they'll start to say, hey, hello. They'll pull you aside and talk to you because this is very expensive. A lot more expensive, right? The first thing I need to appreciate. Okay? Done. Now, how do they look like? Let's take a good look here. This is a measurement for the volume. It looks like this. Okay? Easily can Google. Just Google them, right? So let me just put a bit bigger. Everyone should know how measuring cylinder look like. All right? It looks like this. So it's not very precise. How does a burette look like? It looks like this. All right? Whereby there's a tap and the graduation over here. So when you release the tap, you'll keep dripping down. All right? A pipette, I mentioned, is accurate, but it's fixed volume. If you can strain a bit, this is, I think, 25 cm cube. There's a number there. This is 100. So basically, there is a marking over here. All right? There's a marking over here. The marking not like that, but like that. There's a line somewhere. Okay? For example, I'll just draw that. And remember, when you fill up a liquid, how you fill? You fill to its meniscus. Right? Something like that. Right? You observe it. Something along the line, the meniscus. So again, you fill there, and then you have a fixed volume of 25, fixed volume of 100. And it's considered precise in chemistry because of how it's being made. It's not cheap. Okay? Done. Same like the burette. What else have I not covered? A volumetric flask is for bigger volume, as I mentioned, 100 cm cube or 250 cm cube. Or milliliter, we don't use it in Singapore anymore, but it's the same as cm cube. All right. So as you can see, there's a line here. There's a line here, as you can see here. All right. So you fill it up, you top up, blah, 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 to the meniscus. Okay? Done. Now, this is a volume of liquids. How do we measure the volume of gas? We can use a gas syringe. A gas syringe is used to collect as well as accurately measure small volume of gases. Okay? Typical gas syringe in a chemistry laboratory measures up to 100 cm cube. So you can say this is the limit. Because when it's too big, it's not very accurate and it's very difficult to handle. Okay? Volume, this is your so-called gas syringe. And it looks something, it looks something like this. Okay, there have is lines over there, and therefore you can what? You can read them off the lines over here. Okay, so usually when we have a chemical reaction that produce a gas, the gas go there, and then they'll fill this up. The plunger will move. All right, and then you read them accordingly over here. If you would like to catch my latest videos, click on subscribe button right now. And click on the bell if you want to receive instant notifications once I've uploaded my latest video. If you would like to join my live chemistry classes and revision workshops, go on to winnerseducation.com and find out how you can score distinction for chemistry on a consistent basis, either in our center or online via Zoom. If you want to check out my online school, go on to passwithdistinction.teachable.com. You'll be able to learn chemistry concepts at your own pace and anywhere in the world, topic by topic. This is Sean Chua from Winners Education, to your distinction in chemistry.